Alrighty, we got action. Classifying triangles notes. So this is our first set of notes in our Unit 4, congruent triangles. Some of this on the front should feel real familiar to you. When we get to the back, that you're gonna see stuff that you haven't seen yet. So, two ways to classify triangles: by their angles and by their sides. We're going to talk about classifying them by their angles first. By their angles, if a triangle has three acute angles are any angles less than 90 degrees. So if all three of your angles are less than 90 degrees, and you should be able to see it by sight, then your triangle is called an acute triangle. If your triangle has one obtuse angle, obtuse meaning one angle greater than 90 degrees, then this is an obtuse triangle. If any one angle is greater than 90 degrees, then the triangle is obtuse. Oh, triangle, my bad. Next one is obvious. You got one right angle in your triangle, then we call that a right triangle. And the last one, if all three angles of your triangle are congruent, and they're marking these all as congruent with the same arc marking, then your triangle is called equal angular. Equal angular triangle. It's one word. Equal angular, not equal. Equal angular. Nothing in that, bro. Alright, so using that thought process on them four I just showed you, it says use the diagram, classify each triangle by its angles. Oh, myself. So using this diagram to the right here. Now, understand, you should see a lot of triangles in here. You should see two small ones, another small one, mid-sized one here, then you should have a big triangle that you see all the way around. It's a lot of triangles you should be able to see based on the way they name it. It's another big one in here. Based on the way they name the triangle, you should be able to see what triangle they're talking about. One, the first one says triangle CDE. We classify this by its angles. One, triangle CDE, classify that one by its angle for me. A little bit louder. It's a right triangle. I'm going to abbreviate with the symbol. Irvin, number 2, triangle BCE. I can't hear you. I'm asking one person. I'll get to you. Why are you talking so low, bro? I can't hear you. Obtuse. I'm going to show you the angle that makes it obtuse. That one right there. I'm marking it with 2 markings because these over here, they already marked with 1. And these angles and this one is not congruent. So we got to mark this one differently. So yes, obtuse triangle. Number 3, Faith. Triangle ABE. Okay. Can you try your best? Equal angular? Yeah, okay. So equal angular triangle. Then last one, Chris, triangle BDE. Yeah, Triangle BDE is an obtuse one too. Triangle BDE, y'all should see it right here. The obtuse angle is here. There's a big angle right here. I'm marking it with 3 markings. Alright, so that's classifying it by its angles. You can also classify a triangle by its sides. 3 ways to classify a triangle by its sides, and these should be familiar to y'all. The triangle has 3 congruent sides. Vincent, what do you call that triangle? A little louder, buddy. What? No, we're not talking about the angles no more. Y'all should know this just from other maths y'all took. It's a word. Huh? Oh, good. How you know? Thank you. Oh, you told him? Well, you should have told me. Equilateral. And y'all need to know the difference between the two. Equilateral speaks to the sides. Equiangular speaks to the angles. But they're both talking about the same kind of triangle. Because if a triangle is equiangular, then it has to be equilateral as well. Like I could put, you can see it on here. All these angles are congruent to each other on here. But one thing speaks to sides, the other thing speaks to angles. Equilateral speaks to the sides. Equiangular speaks to the angles. Excuse me. Next one, 2 congruent sides. Dior, the triangle has 2 congruent sides. What kind of triangle do we call that? Let's see it. Oh, buddy. A parallel triangle? Monty. Watch when I give you the letter, everybody gonna know it. This is what's disappointing about it. Y'all have already learned this. Start with an I. Isosceles triangle. What you need, man? Okay. Hold on. So, just talking about this isosceles triangle. Got 2 congruent sides. Alright? 2 sides are congruent, isosceles. I want to remind you. So, when it's none of your sides are congruent, I don't know your name, man. Go ahead. Scalene. So scalene triangle, none of my sides are congruent. If they would ever mark this, when you would see it, as marked as this. It would show you the markings on this triangle like this, showing you that, indicating that none of the sides are the same. Every side has a different amount of markings on it. Alright, sliding down. So using the diagram, classify each triangle by its sides. Trying to think, let's see. Miss Johnson, triangle JKM. Yeah, this was the hardest one to see probably because it's the whole thing. JKM is the big triangle. If you look at the big triangle, the full thing, none of those sides are the same. This is a scalene triangle. My bad. And triangle KLN. Faith, I'm gonna come back to you. Huh? KLN isosceles, good. And then Isaiah, triangle JKN. Say it again. We never named one of the triangles congruent. Thank you. Alright, so 1, 8 through 10, we classify each triangle by its angles and its sides. So we need 2 answers for each one. 1, angles and then sides. Number 8, 1. I want angles first, man. Yeah, so right and it's isosceles. So right and isosceles. Reese, number 9. We're going angles first, man. Obtuse and scalene. Irvin, number 10. Going angles first. Huh? Look at the angles, Irvin. Worst part about it, you're not wrong, but you could be more specific than that. We'll come back to you. DR. He about to make a whole thing out of this. Just say the answers. Nobody heard that. I'm recording, dog. Reese, I'm recording, chill. My bad, got kind of sloppy with that at the end. Equal angular and equilateral. Irvin, you're not wrong that it is an acute triangle, but you can be more specific. Equal angular is more specific for that one. I didn't hear you say that. I thought you said... No, what you said first was equilateral. And I said that, go with the angles first. You never said equal angular. I only got one more to do. Y'all be quiet. The back is the most important piece to me. All that stuff on the front is easy. On the back, the directions say find the distance of each side and classify each triangle by its sides. Keep in simplest radical form if necessary. Out here, they give you a triangle, ABC. They want us to graph that triangle, and they want us to determine what kind of triangle it is. You can't just sit there and look at it and determine what it is. Sometimes you can, but for me, if you want credit on these problems, you're going to have to prove it every time by showing work. Like, on this one you would have to, because it's kind of, this one you can't really see off site. It could be 2 different things. So you need to graph first. You shouldn't be waiting on me to do that. Are we graphing? Yes, sir. You already done grabbed one. So when you sit there, you can't sit there and look at it and tell you what it is going to be. Because to me, it looks like two different things right now. It looks like it could be either be isosceles or equilateral. You can't just determine that by looking at it. You need to do the actual math to figure out which one it's going to be. And y'all should know how to do this math. We've done this before. I told you it ain't going to go away. They said find the distance. How are we going to find the distance from A to B, B to C, and C to A? What are we going to use? The triangle distance formula thing. What's that called? Thank you, sir. Pythagorean theorem. Don't forget it. You ain't gonna stop using it. Shh. Listen, before we do Pythagorean though, what I would sit there and do is make all my triangles. The reason I would do that, so I can compare and see if any are the same. If any of my triangles that I make are the same, then I know I don't need to do that work twice. I can just do it once and then say that those two things both equal that. So let me show you what I'm saying. Draw your triangles out. I'm gonna do all mine in different colors, but just a color code for y'all so we can stay the same. So I'm doing A to B first. Made a right triangle outside of it. My horizontal count is 2. My vertical count is going to be 8. If I count that. Irvin, you paying attention? Don't look like it. Okay. You should be drawing your triangles, bud. Do my other triangle that way for B to C. My horizontal count on B to C is 8. My vertical count is 2. And then I'm going to do C to A last. So do that triangle from C to A. Right triangle outside. Horizontal count is 6. Vertical count is 6. Like I say, once you do all your triangles and you start comparing, I know that AB and BC, those two sides, have the same numbers on my triangles, 2 and 8. So I know that those two values are going to be the same. So I know this triangle is at least going to be isosceles. But I need to do the full check to make sure that it ain't going to be, to make sure that it's not going to be equilateral. Because just because these numbers are different, 6 and 6, when I square these and add them together, they still could give me the same thing that these two are going to give me when I square that together. You need to check. You need to show that work. If you don't show that work, and I'm being clear in what I'm saying right now, if you don't show your work and prove your stuff when you're doing these for me, I will mark the whole thing wrong. You know I will. You've experienced that now. Hopefully I'll start doing your homework correctly. You need to show work on this. Only thing you don't need to show work on is, since these two numbers are the same and these are the same, I'm only going to do this one time and then say AB and BC are the same thing. I hope you understand that. So I'm going to find AB first. Color coding for you. That was the triangle I did in red. AB was 2 squared plus 8 squared equals C squared. You know, C squared is always that diagonal that we're trying to find. And it's 4 plus 8 squared, which is 64, equals C squared. Add that together, you get 68. And then the last thing you need to do is take square root. Irvin, why do I keep speaking to you, dog? Write something down, man. I would leave you alone if I could move you, but I can't move you. I gotta bother you. I'll let you do whatever, but I can't. Alright. What's up? You simplified this? What you gotta go to the restaurant? What's up? Oh, yeah, hurry up. On this, remember, they said at the top they want us to put in simplest radical form. If you can simplify it, you need to simplify it. So we're going to try to break it down and see if we can simplify it. Simplifying it is when we look for those doubles when we break it down. Y'all should remember this. If you can't think of two numbers, if this is an even number, you know you should can always use 2. 2 times what will give me 68? 34. And then I can break that 34 down again too, because this is even. 2 times what will give me 34? 17. Y'all should know that 17 is a prime number. You can't break that down. You're just looking for your doubles. Now, what doubles do I have? The 2's, right? So these 2's are doubled, so that means that I can square root that and bring it out. When I bring it out, it's going to come out as a single, which will be 2. Square root, stay inside the 17 that we can't break down anymore. So AB equals 17, 2 square root 17, excuse me. What does BC equal? Oh, I'm asking, what does BC equal? This ain't no trick question here. Same thing, 2 square root 17. Don't overthink this. Gonna hurt your head if you do. So you already got 2 of your sides right there. Then you just need to check that third side and see if it's equal to these first 2 or not. Third side is going to be CA. So CA is 6 squared plus 6 squared equals C squared. 36 plus 36 equals C squared. 36 plus 36 is 72 equals C squared. Once you get to this point, you kind of know your answer, because I had square root of 68 over here. It's square root of 72. These two are a little bit different, so that tells me already that this side is going to be different. But you're going to finish it out, because you need to finish my problems out. Make sure you break this down into the simplest form if you can, and on this one I think we can. There's better numbers that we can use this time though. You can use 2 and whatever if you don't know nothing else, but 72, y'all should know multiples of that. 8 and 9. So 9 times 8 will give me 72. And then from there, 9 can be broken down to 3 times 3. There goes a set of doubles right there. And then the 8 can be broken down 4 and 2. And then you can split it again. 2 and 2. There go another set of doubles right there. So you got 2 on this one. Let me zoom in a little bit for y'all. Alright, so on this one you should understand that 2 numbers are coming out. 3 and a 2. So on the outside for CA, it's going to be 3 times 2 and square root. What stays under? What did we touch? That 1, 2 right there, right? Yeah, 2. And then you need to simplify that on the outside. CA is 6 square root 2. So AB was 2 square root 17, BC was 2 square root 17, CA was 6 square root 2. Now you can classify by the size, because you know the length of the sides. What kind of triangle is this? Never mind, I'll answer myself. Huh? But that is how you would do it. That's how you show your work and prove that it's an isosceles triangle. Or whatever. It could be isosceles, it could be equilateral, it could be scalene. You need to prove that. Prove what kind of triangle it is on number 12. Do that one on your own. And listen to me. You may not be able to simplify your radicals. Don't get stuck in that. If you can't break it down, you can't break it down. It is what it is. Keep it moving. Just leave it as that. Like say if you get, I don't know, square root of 37. You can't break down square root of 37. Just leave it as that. Square root of 37, that's your answer. Don't overthink it.